conducted on 6th of April, second shift. So without wasting your time, let's start with the discussion. All right, so this is the first question. So we have an object that is moving with an initial speed of 10 meter per second and an acceleration of 2 meter per second square, both along the positive x direction. We want to find the time taken to attain 60 meter per second. So it is simple case of uniform acceleration. All you need is to apply the formula v equals u plus at. We are given the velocity 60 meter per second. We want to find this final velocity. How much time does it take? U is 10, acceleration is given to us 2, and the time taken we need to calculate. So this will be 60 minus 10 over 2, that is 25 seconds. So option 1 is the answer. So that was pretty straightforward question. So JEE Main is making a right combination of easy and hard questions. This is one of the easiest question. Let's move on to the next one. So this is a good question. So the potential energy of an electron is defined by U equals half m omega square x square, and it follows Bohr's law. We want to find the radius of the orbit. So this is based on the Bohr's atomic model. So in Bohr's atomic model, the key idea is mvr, the angular momentum is n times h over 2 pi. So whenever you see this Bohr's law, so first thing that should come to your mind is this. Now we want to find out the radius dependence on n. Here we have mvr is equal to nh by 2 pi. So product of velocity and radius is n times h by 2 pi. I want to think about velocity, only radius. So I need to eliminate velocity. For that, the other information is given to us. The potential energy is given as U is equal to half omega square x square. So using this, I can find the force. Force is minus du by dx. If you don't remember this formula, you can think of this as U is equal to half kx square. And then you know this is the energy of a spring. And you know that the force exerted by spring is kx, negative kx, because force is in opposite direction to the elongation. Otherwise, we can differentiate. And when I differentiate, I'll get it as m omega square x with a negative sign. So negative sign only indicates that this is radially inward. And it is this force which is responsible for the circular motion. So if the electron is revolving in an orbit of radius x with speed v, then the force acting is minus m omega square x. I leave the negative sign. The force is radially inward. Negative only shows that. So this force m omega square x provides the necessary centripetal force. So this is mv square by x. So I get m omega squared x squared is equal to m times v squared. And therefore I get v is equal to omega times x. X is radius. So I'll take x radius also here. And I'll write m into v. V is omega times x. Radius I'll plug in as x is equal to n times h by 2 pi. That gives me x square is equal to n times h over 2 pi m omega. So clearly x is square is proportional to n. So x is proportional to square root of n. Oh, third is the answer. So we have answer 3, option 3. So x proportional to root n. So that was a good question involving multiple steps. This is a very popular kind of question. You should note all these steps carefully. Let's move on to the next one. Okay, so if W is the weight on the surface of Earth, then weight of the same body at a height r by 4 above the surface of Earth. So this is about variation in gravity. Weight on the surface of Earth is mg, and weight at some height is mg prime. Now g prime over g is r square over r plus h whole square. You need to remember this: acceleration due to gravity is inversely proportional to the square of the distance. So g prime over g will be r square over r plus, I'll put h as r by 4 whole square, and that will give me 16 by 25. So that means this weight, W prime, let's call it as W prime. This will be W into 16 by 25, 16 by 25. So second option is the correct answer. Again, that was one of the easy questions. All you needed was to remember this result. All right, let's go on to the next question. So in this question, we have a proton which is projected with the speed v in a magnetic field. Magnetic field is given as 1 Tesla. Angle is given to be 60°. Kinetic energy is 2 electron volt. We'll need to convert this into joules, I guess. Mass of the proton is given. Charge of electron is given. So electronic charge is given. Proton will have same charge. We want to find the pitch. So whenever V is not parallel to B or perpendicular to B, we have a helix. And the pitch of the helix is the component of velocity parallel to magnetic field into the time period of circular motion, which is V cos theta. I'm taking this angle as theta into time period of circular motion in a magnetic field is 2 pi m over qb. So this is what we need to find out. So the required value is 2 pi m v cos theta over q into b. Mass is given to us, charge is given to us, v is given to us, speed is not given to us, but kinetic energy is given. So kinetic energy, we know it is half mv square. So we can be written as square root of 2k over m. So this is 2 pi m by qb into cos theta into square root 2k over m. So this is a good question with a lot of calculations, and you need to be smart to make the calculations properly. This is 2 pi into mass is, okay, so mass is occurring twice. So let's take the things into the square root. So 2 pi cos theta by b, I'll write this as 2 into k into m square over q square times m. Why I have taken q, you will soon understand. So this is now kinetic energy is given as 2 electron volt. So when I have to write 2 electron volt into joules, so I have to multiply with the electronic charge. So it is 2 electron volt, that is 2 into the charge of electron, then it will be in the joule value. So I'll write this k as E into V. This is also E. So this is 2 pi cos theta by B square root. This is 2. This 2 comes from this factor 2, which is given into E, and this M cancels out, and this is E square. So one of the E will cancel out. Now you can plug in the values and solve. That will become easy for you. So to save your time watching this video, I have done this calculation already, and the answer is 6.28 times 10 raised to power minus 4 meter. So answer is option 2. So that was a calculative question. Let's move on to the next question. So we have an electric dipole. This is also a very good question, because in this question, the dipole is given and the charges are minus q and plus q, but their masses are m by 2 and m. Usual question will have same mass and same charge, minus q plus q, but in this case, this is m by 2 m and I'll tell you what difference will it create. So we know that whenever we place a dipole in electric field, it experiences a torque, which is given by PE sine theta. So if this is electric field and the dipole is like this and this angle is theta, then this is going to experience a torque, which is going to make P parallel to E, and this is PE sine theta. For small angles, we can write this as PE theta, because sine theta can be written as theta. Also, if you can see in the diagram, theta is counterclockwise, whereas torque is clockwise. So I should introduce a minus sign. And we know that for oscillations, there has to be a negative sign. Now torque is I alpha. So I alpha, alpha is d square theta over dt square. is equal to minus PE theta. So d square theta over dt square is minus PE over I times theta. This is matching the differential equation. D square x by dt square is equal to minus omega square x. So omega square is PE by I and omega is square root of PE by I. This is what we needed to find out, the angular frequency. Now, the catch in this question is electric field is given, we need to calculate the dipole moment and the moment of inertia. Dipole moment is straightforward, charge into the distance between the charges. Calculating moment of inertia, you have to think. So whenever we have this system freely oscillating, it will be oscillating about its center of mass. Note this point, not the center, but the center of mass. So it is likely that the student may make mistake and they calculate the moment of inertia about center, but it is to be calculated about center of mass. So if I have M1 and M2 separated by a distance L, then the moment of inertia about their center of mass. This is a very interesting result which everyone should know. It is mu times L square, where mu is the symbol for this value. It is just a notation M1 M2 by M1 plus M2, sometimes known as reduced mass. So I we will calculate as M1 M2 over M1 plus M2 times L square. One of the mass is M, other mass is M by 2 over M plus M by 2 times L square. So that gives me I as M by 3. Is it correct? M by 3, M into M by 2 over M plus M by 2. Yes, I is ML square by 3. So you'll take I as ML square by 3 and then you'll find the value of omega. Let's try. Let me check my calculation first. M into M by 2 over M plus M by 2. The denominator will be 3M by 2. Yes, M by 3 into L square. Somehow I'm just feeling that I made some mistake. Let me check it once again. The data is this. Okay, M by 2 and M, right. So now the angular frequency is square root of P E by I. So P is Q times L into E and I is M L square by 3. All right. So this gives me the answer as square root of 3 Q E over M times L. We have any option like this? I guess yes. So this seems to be a misprint. Okay. 3QE by ML. That is the answer. Just take a note on this carefully. So many steps are involved. So I'll give you time. Just have a look at it carefully. Meanwhile, I'll just check my calculations once again. Yes, they seem fine. I was just bothered about this calculation of moment of inertia. That's it. Nothing else. All right. So the answer is 3QE by ML. Option 2 is the correct answer. Fine. Let's go on to the next question. Just give me a moment, please. All right. So let's move on to the next question. In the circuit shown, question number 6, in the circuit shown, reading of the ideal voltmeter we want to find. So when we have an ideal voltmeter, that means it has infinite resistance. So if this resistance is infinite, the current in the circuit will flow like this. And the current would be simply 3 over 3 plus 2. 3 is the voltage and total resistance is 3 plus 2, 5. So 3 by 5 ampere. Now the voltage drop across this 2 ohm resistor will be I times R. That is 3 by 5 into resistance is 2 ohm. So that is 6 by 5, which is 1.2. So answer is 3. Option 3 is the correct answer. Okay, let's go to the next question. Question number 7. Question number 7. We have to find the ratio of the root mean square speed of oxygen gas molecule to that of hydrogen gas molecules. So root mean square, VRMS. VRMS is square root of 3RT by M, where M is the molecular mass. So temperature is same. So all we need is to compare the ratio of molecular masses. So root mean square speed of oxygen to hydrogen. This will be square root. Molecular mass of hydrogen will be on the upper side, and downstairs I'll have molecular mass of oxygen, and molecular mass of hydrogen gas is 2 grams and molecular mass of oxygen is 32 grams. So this is, I should have taken in kg, but since this is a ratio, it will cancel out. So 1/4. So answer is 1/4. Option 1 is the correct answer. That was a straightforward question. Let's move on to the next question. Question number 8. Question number 8. In amplitude modulation, we are given carrier frequency, modulation frequency. The index modulation is 60%. Index of modulation 60%, that is 60 by 100. It is the ratio of the amplitude of the modulating signal and the carrier wave frequency. So we are given AM over AC as 60 by 100, which is 3/5. Now we are given AC minus AM and we want to find AC plus AM. One of the nice way would be, let's write this as AC by M is equal to 5/3. And then we use componendo and dividendo. Short, we write C and D. By componendo of dividendo, I'll write AC plus AM over AC minus AM is equal to 5 plus 3 over 5 minus 3. That is 8/2, which is 4. So AC plus AM is simply 4 times AC minus AM. So 12 volt must be the answer. So option 2 is the correct answer. Otherwise, you can use this equation and this equation to find the values of AC and AM. Then you can find AC plus AM. But this is pretty straightforward way of solving the same thing. So I hope that works for you. Let's go on to the next question. We have two different photosensitive materials having function phi and 2 phi. They are illuminated with the light of sufficient energy to emit electrons. Okay. If we are drawing a graph of stopping potential versus frequency, that is a very famous graph. So we are drawing a graph between stopping potential and frequency. And we want to compare the slope. This is a very important point to note. For that, we need the equation. Equation is HF, the incident energy, minus work function phi is equal to maximum kinetic energy, which is E into V, where V is the stopping potential. Let's call it as V naught, E into V naught. So I can write V naught as H over E times F minus phi over E. Now this is a straight line of the form Y equals mx plus c. So slope is h by e. So whenever we draw a graph, the slope comes out to be h by e. So this slope is independent of the nature of the metal chosen for which we are observing the photoelectric effect. That is a very important result. So it is h by e. It is a universal constant because h and e both are fixed values. So answer is 1:1. Note these points carefully, that slope is independent of the nature of the material whenever we draw the graph between stopping potential and frequency. All right, let's go on to the next question. So we are given an AC circuit. We want the maximum current, so peak value. So some data is missing in this. I have a hard copy of printout with me also, and it is given over there that this EMF is 36 sine 120 pi t. So that is the EMF. Now the peak value of current will be the peak value of EMF divided by the capacitive reactance XC. And the capacitive reactance is 1 over omega C. You need to remember these results. So I naught can be written as E naught times omega times C. So this is nothing but straightforward calculation. EMF peak value is 36, omega is 120 pi, and capacitance is 150 microfarad. Micro is 10 to minus 6, so we need to solve this value. To save your time, I already have this solved, 0.65 pi ampere. So that is the first answer. All right, that's a cool one. Next, go for the next question. An object is released from a height h such that ratio of its speed before striking the ground and after striking the ground is 4:1. So it strikes the ground with the speed 4u and it rebounds with the speed u. So that means its kinetic energy after rebound is k and before rebound is 16k. The loss of kinetic energy. Loss of kinetic energy would be 16k minus k. This is the loss divided by the original value. This will make it percent into 100. So the loss of kinetic energy is x over 4%. So this is what we need to solve. This is 15 over 16 is equal to x by 4%. So x by 4, this percentage value is x by 4. So I don't have to multiply this by 100. So x by 4%. So this percentage change in kinetic energy is x by 4. So 15 by 16. So 1500 by 16 is equal to x by 4. So x is 1500 divided by 4, which is 375. So answer is 375. So option 3 is the correct answer. All right, let's go on to the next question. This is an assertion reason. Since this is a memory-based question, I believe this statement is not properly written. So when a toothpaste is pressed, it follows Pascal's principle. So when a toothpaste is pressed, we see the paste coming out, because when we increase the pressure at some place, that pressure increment is transmitted everywhere, and therefore the paste comes out of the mouth. And the reason is the same statement which I used to explain this. So reason clearly explains the assertion that when the pressure is applied on a fluid, it is distributed constantly through the fluid in all directions. So option 1 is the answer. Assertion is correct, reason is correct, and it is the explanation also. Next question. So in forward bias PN junction, diffusion current is from P region to N region. Diffusion takes place due to concentration gradient. So in a PN junction, this is P, this is N. P type have majority charge carriers as holes. N type has majority charge carriers as electrons. And the diffusion is due to concentration gradient. That is a correct statement. And from higher concentration to lower concentration, holes move from P to N. And therefore, the direction of the diffusion current is from P side to N side. So clearly, the reason is the proper explanation of the assertion. So answer 1. That was an easy question. All right, let's move to the next. So we have a radius of first orbit and the hydrogen atom is A0. We want to find the de Broglie wavelength of electron in the third orbit. Wavelength can be related to momentum. De Broglie formula. Lambda is h over mv. And hydrogen atom, we know that mvr is n times h over 2 pi. And r for hydrogen atom is r0 times n square, where r0 is the radius of the first hydrogen atom. So it is a0 times n square. So let's put in the value. mv I will replace by h over lambda. R I will replace as a0 times n square. And this is n times h over 2 pi. So I'll get lambda is equal to 2 pi a0 times n. Everything else will cancel out. So now third orbit. Third orbit means n is 3, n is 3, so this becomes 6 pi a naught. So answer 2 is the correct answer. All right, let's go on to the next one. Question number 15. You want to find the incorrect statement. Okay, so only one of them is incorrect. So let's find the incorrect. Planets revolve around sun with constant linear speed. No. Planets revolve around the sun in elliptical orbits. And since their distance from the sun is changing, their gravitational potential energy is changing, and therefore kinetic energy is also changing. In fact, we know that when they are closing in, they are moving fast, and when they are away from the sun, they are moving slow. So this is wrong. Just for the sake of general knowledge, let's check the other thing. Energy of the planet in elliptical orbit is constant. Total energy is always constant for the planets. It does not depend on the nature of the orbit. Satellites in the circular motion have constant energy. Yes, constant in elliptical orbit, both total energy is fixed. Body falling towards the earth results in negligible displacement of earth. So that is also correct, since earth is very massive. So the displacement of earth is negligibly small. So whenever you drop a body, it falls down. You don't see earth moving up. So B, C, D are correct. Only A is incorrect. So answer is option A. All right, the next question. We have a particle moving from A to B via C. Okay, so it goes like this. With the uniform speed of 5 meters per second, we want to find average velocity. Now, average velocity is displacement upon time. So let's find the displacement. Time also. So displacement is the shortest distance between initial and final position. So I want to find this length AB. Say this is radius R, this is radius R, and I want to find AB. So this is an isosceles triangle. This angle will be 30 degree and this will be 30 degree because total sum is 180. I can use law of sines. So the distance AB over sine of the angle opposite to that 120 is equal to the distance OA over sine of the angle opposite to that 30 degree. So that gives you AB is equal to R into sine 120 over sine 30. Sine 120 is as good as sine 60. So root 3R. So AB is root 3R. Now how to find the time? To find the time, I need to take the arc length AB and I need to divide it by speed. Speed is pi. And the arc length AB will be radius into the angle. Angle is 120 degree. 120, we need to convert it into radians. So this is 2 pi by 3. So 2 pi r by 3. So we'll fit in the values. This is root 3r over 2 pi r by 3. So the answer is 3 root 3 over 2 meter per second. So this one. You can try this for a general angle theta. Instead of taking angle 120 degree, try for angle theta. All right, let's go on to the next one. Question number 17. We are given the temperature of a body drops from 60 to 40 in 7 minutes. Surrounding temperature is 10. The temperature drops from 40 to 10 in 7 minutes. Find the value of T. So this is based on Newton's law of cooling. And for solving such questions, we have an approximate formula. And that approximate formula is the fall in temperature divided by the time taken. So this is the average rate of cooling. This is equal to K times some constant times average temperature difference. So if the body temperature goes down from T1 to T2 in the surrounding of temperature T0, Then average temperature of the body while it cools down from T1 to T2 is taken as arithmetic mean, and T0 is the surrounding temperature. So T1 minus T2 by T is equal to K times T1 plus T2 by 2 minus T0. This is the formula to be used in this. We just have to write this formula 2 times. So in first case, the body cools from 60 to 40 in 7 minutes. So I'll write 60 plus 40 by 2 minus the temperature of the surrounding, which is 10. In the second case, body cools from 40 to T. So 40 minus T over time is again 7 minutes is equal to K times 40 plus T by 2 average temperature minus 10. So divide these two equations to remove K, which is not known to us. So when we divide, K gets cancelled out. So I'll be left with 20 over 40 minus T on the left hand side is equal to, this is 60 plus 40 by 2, 50 minus 10, 40 over 40 plus T by 2 minus 10. And then we can solve for T. So if I solve it, I'll get T as 28 degrees Celsius. So to save your time again, the calculation I have done already. So the answer is 28 degrees Celsius. Just reduce the size to have a complete look at the picture. So this is the standard problem, standard data question also given in NCERT on this, Newton's law of cooling. Anyway, let's move to the next question. In the circuit, we want to find the current passing through the 20 ohm resistor. So this is a circuit. We are given the potentials of these points, and I want to find the current here. So to find the current, I need potential difference. For that matter, if somehow I am able to find the potential of this point, then I can write V minus 2 potential difference divided by resistance is the current. So this is what I want. So to be able to calculate the current, I need to find the potential. So to find the potential, I will make use of Kirchhoff's law, current law. Suppose current comes through 60 ohm and it divides into two branches. So the current through 60 ohm will be 30 minus V divided by 60, potential difference divided by resistance. This must be equal to the current going up plus current going down. Now the current going up will be the current through 20 ohm, which is V minus 20, the potential difference, sorry, V minus 20. It is V minus 2 divided by 20 plus the current going down, it is 6, sorry, it is V minus 12 over 30, right? So we'll solve this equation for V. So this is, let's multiply this whole thing by 60. So I get 30 minus V is equal to 3V minus 4 plus 2V minus 24. So 3V, 2V, 5V plus V, 6V, and this is 30 plus 4, 34, 38, 48. So I'll get V as 8 volt. So if I get V as 8 volt, the current will be V minus 2, 8 minus 2 by 20, that is 6 by 20. Did I make some mistake? Looks like I have done some calculation mistake. Let's check it. So I multiplied this whole thing by 60. So this is 30 minus V. This is 3V minus 6 because this thing will be multiplied. So 24, 30, right? So this is 60 actually. So V is not 8 volt, V is 10 volt. So if V is 10 volt, then the current is 10 minus 2 by 20, that is 8 by 20, 0.4 ampere. So 0.4 ampere. That is the answer. All right. Let's go to the next question. Question number 19. This is just a formula based question. The average energy density of an EM wave. We are given electric field amplitude and magnetic field amplitude. The average energy density of an EM wave is equally distributed between electric field and magnetic field. For your general knowledge, I am writing down various formulas involved. One is half epsilon naught E RMS square plus half B RMS squared by mu naught. We know that E RMS is E naught by root 2. In AC circuits, we do this. RMS value is peak value by root 2. So this formula will then become 1 by 4 epsilon naught E naught square plus 1 by 4 B naught square by mu naught. In addition to this, these two terms are equal to each other. So this can be written as twice of half epsilon naught, sorry, not half, twice of 1 by 4 epsilon naught E naught square, or twice of 1 by 4 B naught square by mu naught. So this becomes then half epsilon naught E naught square and also B naught square by 2 mu naught. So this is the average energy density total. So is there any option matching with this? Okay, option 1 is the correct answer. So note down all these results. It will be useful for you. All right, let's move on to the next question. This is the last question in this memory-based thing. We have a solid sphere and a ring. They have equal mass and equal radius of gyration. Moment of inertia is mass into radius of gyration square. So if mass and radius of gyration are same, that means moment of inertia is same. So this question is about equating the moment of inertia. Okay, so mass of the solid sphere is m, moment of inertia is 2 by 5, mass into radius square. This is the moment of inertia of a solid sphere. And for a ring, the moment of inertia will be mr square. So m into r of the ring squared. So m are given equal. So this gives you radius, the sphere squared over radius of the ring squared is equal to 5 over 2. So the radius ratio will come out to be root of 5 by 2. And we have to compare it with root of x by 2. So I'll get x equals 5 here. So the given answer. So this is a numerical answer. Answer is 5. So that brings me to the closure of this question paper. All these questions were based on memory. So whatever questions we are able to collect, their solutions have been given to you. Keep watching for other shift solutions also. They will be available right here. Thank you.